Hello everyone. In this video, we talk about motion graphs. And in our process of describing the objects in motion, motion graphs, the position versus time, velocity versus time, acceleration versus time graphs do a lot for us. In fact, we should be able to look at the slope of the position versus time graphs to describe how the velocity is changing with time. Look at the slope right here for the position versus time graph. And look at the velocity versus time graph's slope. To talk about the acceleration, we can describe how the acceleration is changing with time. So in this video, we talk about 4 types of these motion, and we try to go between each motion graph, PT, VT, and AT for all 4 of these types. The basic one we could get, there's an object right here, would be at rest, not in motion. Here in this example, we have an object stationary and it is at the positive X side. And here we have the horizontal segment showing that information. And when we look at the definition itself, 0 speed at rest, it should be velocity 0. Also, we can relate the slope of this position versus time graph. It is a 0. We can see that here. Again, not in motion, acceleration should be 0. Slope of the velocity versus time graph for this horizontal segment, it is a 0. Here we see that information. The idea is to go more complicated scenarios using these definitions, relationships to go between these motion graphs. Here in this video, we have a car moving in the positive X direction with a constant velocity. Moving in the positive direction, here we go with the time is increasing, position is increasing. When we look at this relationship right here, velocity is equal to the slope of the position versus time graph. We have a constant positive slope, which means we should have a positive constant velocity. Here we see that information. And looking at the constant velocity, it means speed kept constant along a certain direction, constant velocity. Acceleration should be 0. Here we go, we see that 0 acceleration for this constant velocity motion. Here in this video, we have an object starting from rest, but moving with constant acceleration. Constant acceleration towards the positive direction. Here we go. We see the positive acceleration. And according to this relationship, in the velocity versus time graph, the slope is the acceleration. Looking at this guy, velocity versus time graph, it has a positive slope and a constant slope. So constant positive slope in the velocity versus time graph. Here we see that constant acceleration. Looking at this relationship, slope of the displacement, slope of the position versus time graph is the velocity. Looking at the position versus time graph here, the slope is positive, but it keeps increasing, getting steeper and steeper. Should be the velocity positively increasing. In this graph, we see as the clock is ticking, time increasing, velocity keeps increasing. So these are related not only in these definitions, we can see that in these motion graphs. Here we have an deceleration motion. The object is moving, but you apply the brake, the car is slowing down. Here we have still the object is moving in the positive direction, positive X direction. When the time is increasing, the position is increasing. But slope right here, slope is decreasing. Here we go. Velocity number is decreasing for the slowing down motion. It had a big number, but it is decreasing, slowing down. Looking at the velocity versus time graph, the slope is the acceleration. It is a negative constant slope. Here we go, constant negative number for the acceleration. Okay, so deceleration. We already did talk about this car is moving in a flat road with constant acceleration. But in the lab number 2, inclined plane motion, you will see an example of a block sliding down on an inclined surface. No matter what's going on, if it is a constant acceleration, no matter if it is flat or if it is a slope, you will see the same shapes, position versus time, velocity versus time, acceleration versus time. All it matters, the relationships between the slope of these motion graphs.